If you plan to become a web developer, this overview course will be helpful for you. The ultimate goal of web development is to provide a website. A website is essentially an application running on a publicly accessible server. You can access a website by entering the server's address along with the port used by the application in your browser's address bar. However, remembering server addresses is cumbersome, so developers usually register a domain name with a domain registrar and use the domain name instead of the IPv4 or IPv6 address. In most cases, developers deploy services on standard ports. HTTP uses port 80 and HTTPS uses port 443, so the port number can often be omitted and the browser will fill it in automatically. This is the type of URL we see in everyday life, which can uniquely identify a specific website on the internet. Now, let's talk about the system architecture of a website service. A website that you can access through a browser basically has two jobs. First, when you visit it, it needs to tell your browser correctly what the website should look like. Second, when your browser sends a request, like searching for information, the server needs to process the data properly, send the results back to the browser, and update the page. Simply put, one part defines the website's interface, which we call the front-end service. The other part defines the website's business logic, which we call the back-end service. In the early days of web development, the front-end and back-end were usually built together in the same project. This is what we call full-stack development. But in modern development, it's more common to separate them. Although it still looks like a single website from the outside, the front-end and back-end are often deployed independently and communicate via protocols such as HTTP or HTTPS. This is called a front-end back-end separated architecture. That said, for small projects, full-stack development is still very popular. Frameworks like Next.js, Flask, and Django all support full-stack development. So by now, you probably understand. Learning web development means mastering both front-end and back-end technologies. My suggestion is to start with the front-end. It's relatively simple and gives you quick, visible results. Back-end development depends more on specific business scenarios, so if you don't have your own project, it can be harder to practice at first. The core task of the front-end service is to tell the browser what the website's interface looks like. This can be further divided into three parts: content, style, and interactivity. For example, the website I'm showing you right now has a title and a body. The title and body text are the content. The title size is 20px and the body text is 16px, which represents the style. Clicking the title to show or hide the body is the interactivity. As long as you can correctly describe these three parts, you can create almost unlimited possibilities. These three parts are primarily handled using three languages in the front end. HTML describes the content, CSS describes the style, JavaScript describes the interactivity. Finally, the CSS and JavaScript code are integrated with the HTML and returned together to the browser. Since this video is an overview, we won't go into the syntax here. Later tutorials will cover that in detail. In short, the main job of the front-end service is to return the corresponding HTML of the website, which the browser can then render. It sounds simple, but front-end development itself has different technical approaches. The most common distinction is between static websites and dynamic websites. A static website works by having all HTML files pre-written and stored on the server. When a user visits, the front-end service simply returns the corresponding file. For example, the homepage is usually index.html in the root directory. You can access it via index.html. The index.html can be omitted. Subpages work similarly. If you have about.html, visiting about.html will open it. If the file is products, index.html, visiting products will open it. This is how static websites work. They are fast and everyone sees the same content because all users receive the same file. Many blogs and tutorial websites are built this way. However, in reality, many websites need to display different content for different users or requests. For example, each user's homepage should display personalized content. A search engine should display different search results depending on the query. Static websites cannot handle these scenarios, which is why dynamic websites exist, also called server-side rendering. The principle of a dynamic website is this. When you visit a site, the server doesn't simply read a pre-written HTML file and send it back. Instead, it uses a template and the information you provide to generate HTML on the fly, and then returns it to your browser. This means that each person can get a different page, and even the same person may see different content if they provide different information. In this scenario, users can provide information in several ways. First, through path parameters, which pass data as part of the URL. For example, if you visit home Mark here, the server knows to show Mark's homepage. It fetches Mark's information from the database, fills it into a template, generates the corresponding HTML, and sends it back to your browser. Essentially, Mark's homepage is a web page generated using Mark's data. This approach is actually designed to be compatible with the way people access static websites. It looks like you're visiting a fixed file path, but the content is generated dynamically by the server. Second, through query parameters, which provide data using key value in the URL. Google search works this way. You'll see something like $Q keyword in the address bar, where the keyword is sent to the server. The server processes the data and generates the HTML with the search results, so you see a page with the results. There are also parameters that don't appear in the URL, but are sent as additional data, such as request headers, request bodies, or cookies. These usually include your personal information, allows the website to identify who you are. You can think of it as your ID card for that web application. In most SaaS services, there's usually a login feature. The basic principle is that after you register, the website assigns you an identifier and stores it on your device. Each time you visit the site afterward, this identity information is sent along with your request. This way, the website recognizes you and brings you to your personal homepage. This is essentially what logging in means. Now, let's briefly talk about front-end development. For static websites, you only need to write HTML, CSS, and JavaScript directly. If you want to go live, many providers offer free static hosting services. GitHub Pages is a great example. You just upload your code to the platform without needing to buy a server, and your website becomes publicly accessible. For dynamic websites, things are a bit different. They rely on frameworks and run as applications on a server, handling the dynamic rendering of web content. Popular frameworks include Flask and Django in the Python ecosystem, and Next.js and Express in the JavaScript ecosystem. They all provide tools to help you pass request parameters, render HTML dynamically, and send it back to the client. Personally, I recommend Next.js, one of the most popular web frameworks today. It's based on React and uses JavaScript's extended syntax JSX, letting you create reusable components. Compared with classic frameworks like Flask, Django, or Express, Next.js projects are often more maintainable and readable. Most server providers support Next.js, which makes deployment easier. If you're more comfortable in the Python ecosystem, Flask is a simple and good choice, while Django might feel a bit heavy for beginners. Next, let's look at the backend. Like the front-end, backend services usually run on separate servers or ports, and the front-end accesses them via HTTP or HTTPS requests. The backend's main job is to interact with the front-end, handle complex business logic, and return the necessary data. For example, imagine a news website where the front-end wants to show the top 10 trending articles of the day. The front-end sends a request to the backend. The backend might query the database, sort and analyze the data, maybe even run predictive analysis, and then return the results. The front-end takes this data and builds the corresponding HTML to display in the browser. From the perspective of requests, fetching data from the backend is very similar to accessing a web page. Both use HTTP or HTTPS, and the request carries information to query data. The methods of sending information are the same as we discussed before: path parameters, query parameters, and additional data. The difference is that the backend usually doesn't return full HTML. Instead, it sends structured data, most commonly in JSON format. The frontend can then parse and process the JSON and render it into a page. This kind of service, which returns specific data over HTTP or HTTPS, is generally called a RESTful API. Most backend APIs are invisible to regular users, but some well-known sites, like OpenAI and Google, open parts of their APIs for developers. This allows developers to build their own applications using these services. Compared with front-end development, back-end technology choices are much more complex. In fact, in large websites, a single front-end service often depends on multiple back-end services. Each back-end might use a different language or framework depending on the scenario. For example, Python with Django, Flask or Fast API, JavaScript with Node.js and Express, and Java with Spring. For beginners, my recommendation is to start with Fast API. It's based on Python, with a syntax style similar to Flask, making it simple and easy to learn. It's also designed according to modern web development best practices, and its performance is among the top in Python web frameworks. Because of this, Fast API is becoming increasingly popular in the industry. Finally, you might have noticed when I introduced server-side rendering that if a front-end service needs to fetch user data, it could technically query the database directly without going through a back-end service. This approach, where a single server handles both web page content and business logic, is essentially what we call full-stack development. For simple websites or applications, this is perfectly fine. However, for more complex applications with intricate page interactions and business logic, putting all code in a single service becomes extremely difficult to manage. From my perspective, I recommend designing your web applications with a front-end back-end separation architecture. It may feel painful at first, but as your project grows, you'll be grateful for this decision. Thanks for watching. This was a quick overview of web development. In the future, we'll dive deeper into the details, exploring different languages and frameworks. If you enjoy my teaching style, don't forget to follow me. I'll keep sharing useful content. I'm Mark, and I'll see you next time.